talking about similar polygons. Similar polygons have congruent corresponding angles and the corresponding sides are proportional. So the corresponding angles are congruent and the corresponding sides form a proportion. You can see the proportion here easily. You've been doing this for many years. So you'd have here that given that these are similar, you'd have 1 is to 3 as 2 is to 6. Yes, that's a valid proportion. You've been doing it for a long time, but now we're just taking notice of it and stating it formally. The scale factor and ratio will work here. Let's see how that works. Talking about scale factor and ratio, in math, we tend to be very specific about our terminology on this. A caveat of aware, everybody's not this specific about it, and so you will have to look carefully when you're dealing with something to see whether they're talking about scale factor or ratio, sometimes even in your workbook that goes with our book. So let's look at the distinction here. Scale factor is what you multiply by to get from one to the other. So here I have my small blue rectangle, my big blue rectangle. I have the measurement 3 and 5. What do I multiply 3 by to get 5? Well, of course, it's 5 over 3. 3 times 5 over 3 is 5. So I'll multiply the other dimensional measurement, x, by 5 over 3 to get my other side. Scale factor. Factor means multiplying. So what do you multiply by? Multiply by 5 over 3 to go from here to here. Ratio, however, talks about the relationships between the two numbers, and we always state the ratio in the order that it's given to us. So here we have the small one first and then the big one. We have the small one with 3, the big one with 5, so we state the ratio as 3 to 5. Written as a fraction, it's 3 over 5. Notice that the scale factor and the ratio are reciprocals when technically and specifically examined. So the scale factor 5 over 3, the ratio 3 over 5. We're talking about different aspects of these drawings, and they are reciprocals. You'll have to be careful to make sure that you know what you're doing when you do it. So let's look at a theorem that has to do with this. You're already very familiar with using this. You might not be recalling that it also works for the perimeter. So here we have that polygon quadrilateral ABCD is similar to quadrilateral PQRS. By the definition, the sides are proportional. The corresponding sides provide proportions, but also all of the linear measurements in it are also proportional. So let's look here. Are these two polygons, quadrilaterals, similar? If they are, tell me a similarity statement. All the corresponding angles are the same. Are the corresponding sides in the same ratio? We can write a similarity statement. Remember, you're going to start at the same place and go around. It doesn't matter where you start. I'm going to start at H because my name starts with Hamilton. Hamilton starts with an H. And then you either go clockwise or counterclockwise in order. So this will be polygon H, quadrilateral, G, F, J, and it is similar to start in the corresponding one now, the one with 2, X, Y, Z, W. So again, just like triangles, you have to write them in the same order. Try this problem. Remember that it's stated there that it is similar, which means the sides are proportional, so you can work that one out. And let's look at this problem. During a total eclipse of the sun, the moon is directly in line with the sun and blocks the sun rays. The distance ED between Earth and the moon is about 24,000 miles. The distance DA between the Earth and the sun is 93,000 miles. And the radius AB of the sun is 432,500 miles. Here I've labeled parts of it which may be helpful to you. Notice that you have similar triangles. Because of the orientation of the sun and the moon, the radii will be parallel. The side of the triangle will be parallel, which means all of the angles are the same. So we have all of the angles congruent, making it similar. So the sides are proportional. You can set up a proportion to estimate the radius of the moon. So the radius of the sun is to the distance as the radius of the moon is to the distance. So go ahead and try that. And here endeth this lesson.